Okay, this is section 5.6, Inequalities in one triangle. So what we want to do today is we want to be able to use those inequalities involving angles and the sides of triangles. So what we want to recognize today is that angles and sides of a triangle have special relationships that involve inequalities. And as we go through a little bit more, you'll be able to see that. So let's start off with the comparison property of inequality. So they say if A equals B plus C and C is greater than 0, then A is greater than B. So I find that impossible to understand. So I do better if I've got something concrete in there. So let's plug in some numbers. So if A, let's say A is 5, is equal to 3 plus 2. So I've got A is equal to B plus C. And I see C is greater than 0 because it's 2 right here. Then A is greater than B. Okay, so I'm just adding this up. So the sum is larger than either of its parts. So let's try this again with a different number. Let's do 5 again. Say 5 is equal to 4 plus 1. Okay, C is greater than 0, B is 4, and A is 5. So A is greater than B, or 5 is greater than 4. So what we're going to do, we're going to use the comparison property of inequality with the triangle exterior angle theorem, and we're going to find some interesting things. So let's go back first and look at the triangle exterior angle theorem. Remember, so angle 1 is equal to the measure of angle 2 plus the measure of angle 3. Remember that? So let's take a look at the corollary. So the corollary says the measure of an exterior angle, in this case it's 1. Okay, the measure of an exterior angle of a triangle is greater than the measure of each of its remote interior angles. So angle 1 is an exterior angle, so that means the measure of angle 1 is greater than the measure of angle 2, and the measure of angle 1 is greater than the measure of angle 3. Okay, let's see if we can apply that. So we're going to use the figure at the right, and it wants to know why is the measure of angle 2 greater than the measure of angle 3. Okay, so when I first look at this, I'm like, how am I supposed to relate angle 2 to angle 3? They do not give me a single measurement. What am I supposed to do? But then I look and see that segment BC is congruent to segment CD. Oh, so what does that mean? What kind of triangle is that? So that's an isosceles triangle. So let's see. So I have an isosceles triangle. So what does that tell me about the measure of angle 1 and the measure of angle 2? Well, that tells me that the measure of angle 1 is equal to the measure of angle 2. Oh, now I see I've got 1 and this triangle ABD is an exterior angle, and I know that if I add up angles 3 and 4, they will sum to give me angle 1. So I know that the measure of angle 1 is greater than the measure of angle 3. Oh, but it wants me to do something with measure of angle 2. How can I do that? Oh, the measure of angle 1 and 2 are congruent. They're equal. So now I can just say the measure of angle 2 is greater than the measure of angle 3, and I can do that because of my handy-dandy substitution property. So this problem wasn't as scary as it looked at the onset. So now we're on to Theorem 510. So the theorem says, if two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. So xz is greater than xy, so the measure of angle y is greater than the measure of angle z. The longest side has the largest angle, or the longest side is opposite of the largest angle. Now let's take a look at this problem. A town park is triangular. A landscape architect wants to place a bench at the corner with the largest angle. Which two streets form the corner with the largest angle? Well, I just learned over here that the largest angle is opposite the longest side. Which side is longest? Hollingsworth Road, the 175 yards. So which angle is larger? So my largest angle is going to be the corner of MLK Boulevard and Valley Road. Now let's suppose the landscape architect wants to place a drinking fountain at the corner with the second largest angle. Where is that going to be? Okay, so we've used Hollingsworth Road already, so that's the longest. Valley Road is the second longest. So the water fountain is going to be right over here, the corner of MLK and Hollingsworth. Now let's take a look at Theorem 511. So Theorem 511 tells me if two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. Wait a second. If two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. So those two go together, so I know that if the measure of angle A is greater than the measure of angle B, then segment BC is larger than segment AC. Okay, now we're going to look at this problem. So which choice shows the sides of triangle TUV in order from shortest to longest? So I have this triangle. I have two of the angles. Which angle do I not have? I don't have angle T. How can I find angle T? I know when I add up angle U and V and T, it's going to equal 180. So I'm going to say 180 minus 58 plus 62. And so that's going to be 180 minus 120. So T here is equal to 60 degrees. So they want from shortest to longest. So how am I going to do that? I'm going to start with the smallest angle, right? So 58 is my smallest angle, and that's opposite of TV. So A starts with TV and D starts with TV. So I can cross out B and I can cross out C. Next, I have 60 degrees is my next smaller number, or my next number up. So that will be UV. So I can stop right there. So it is TV, UV, UT. Okay, so earlier in the year, we kind of discovered this, but it's worth repeating. For three segments to form a triangle, their lengths must be related in a certain way. Notice that only one set of the segments below can form a triangle. The sum of the smallest two lengths must be greater than the greatest length. So in this case, the two smallest lengths are 3. 3 plus 3 gives me 6, and it is greater than 5. Over here we have 2, 2, and 6. The two smallers are 2. 2 plus 2 is 4. 4 is not greater than 6, so I kind of have an incomplete triangle. So this brings us to Theorem 512, the triangle inequality theorem. So it simply says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So if I said xy plus yz, that's definitely going to be greater than xz. And the same here, yz plus zx is greater than xy. So if I add up the two sides, it's going to be, any two sides, it's going to be greater than the third. Okay, so I'm going to leave this so I can see the bottom part of those x's. So let's see, can a triangle have sides with a given lengths? So the first one is 3, 7, and 8. So I'm going to set up my three inequalities. So I'm going to say 3 plus 7 is greater than 8. Then I'm going to say 7 plus 8 is greater than 3. And then I'm going to say 8 plus 3 is greater than 7. Okay, so 10 is greater than 8. That's true. 7 plus 8, that's 15, is greater than 3. So that works out. And then 8, 9, 10, 11. 11 is greater than 7. So that works out. So I want you to take a second, go ahead and hit pause and see what you come up with. Okay, so I set my three inequalities up, and I really didn't have to, because 5 plus 10 gives me what? 15 is greater than 15. Well, that's not true. So this one does not work. So a triangle with the sides of 5, 10, and 15 does not exist. So I could have saved my time and not even written out these other two, because 15 is not greater than 15. Okay, this is the last problem, and on your paper, if you chose to use the notes template, you'll notice that I put the triangular inequality theorem there for you to reference in case you need it. So that's what that's doing there. So anyway, so now we have a dimensions of a triangular sandbox. Two of the sides are 5 feet long and 8 feet. What is the range of the possible lengths for the third side? So I'm going to use x for my third side. So I've got sides that are x, 5, and 8. So now I'm going to set up use my triangular inequality theorem over here. So I'm going to say, first I'm going to say x plus 5 is greater than 8. Next I'm going to say 5 plus 8 is greater than x. So I want you to notice that these are the three sides. So I took two of the sides, and they've got to be greater than the third. I took two of the sides, and they have to be greater than the third. So next, let's see, which one do I have left? X plus 8 is greater than 5. So I'm going to solve this. Subtract 5 from both sides. So x is greater than 3. 5 plus 8 is 13. 13 is greater than x. Or I can write that, I'm going to read it backwards, or x is less than 13. Going to subtract 8. So x is greater than -3. Well, I can't have a side that has a negative value, so I'm not even going to consider this one. So I know that my board has to be greater than 3 feet, and smaller than what? And smaller than 13. Okay, so if any of this material gave you any trouble, you can go back to the areas, pause, and bring your questions to class. Thanks a lot.